Hello and welcome to a new unit of the iGCSE Computer Science syllabus with me, CS with Mr. G. Unit 3 is all about hardware, so parts of the computer, and this unit covers the internal components of a computer and the external components, requiring you to know the roles and responsibilities of the different components, how they work together to form a computer, and in particular today we are going to look at computer architecture, which refers to the CPU. So we are currently here within the syllabus. So far we've looked at data representation and data transmission, and now we're looking at hardware, and like I said, this is all the parts of the computer and any physical aspect to a computer that you can touch or at least see inside a computer, and are the building blocks to any device, not just desktop PCs like in the image there, but also laptops, phones, tablets. All of these devices are built with the same hardware, but they come in many different shapes and sizes. So in this lesson, we need to understand what the CPU is, the central processing unit, and understand its job and what it does in terms of a computer system. This term microprocessor, which is also very similar to the CPU, and often the word can be used interchangeably, and we'll cover the basics of that also. We'll also cover this term von Neumann architecture, which relates to the CPU and RAM. And then finally, the Fetch-Decode-Execute Cycle, which is the CPU's main function when it comes to processing instructions. So with my classes prior to this course, we would have at least covered the basics of a computer, which includes all of the parts inside, so the CPU, the RAM, a hard drive, the difference between primary and secondary storage. So if you're completely new to this, it might be worth you skipping ahead and covering the basics of the parts that are more easily understandable before we jump into this topic here, because the CPU can be quite tricky, as there are other parts involved with the CPU, and the CPU itself has many different components which we need to understand and obviously explain when it comes to an exam. So like I said, if you need to, go and cover the basics first. Maybe skip ahead in Unit 3 with me. I will put a link in the description of some of the videos I suggest watching first. But at the very least, I would cover the basics of input and output devices and maybe the difference between main memory and secondary storage. So I'm not going to go over that in this lesson. This is strictly about the CPU. But by all means, go and do some research first and then come back to this one. Okay, so as you can see, the CPU lies in the middle of all of these devices. We've got main memory up here, which is RAM. And we've also got secondary storage here, which is your hard disk drive or your SSD. We've also got input devices, so things like your mouse, your keyboard, or any other input devices that you can think of, such as a camera, a scanner. All of these devices come under the category of input. And as you can see, this passes information into the CPU, and then the CPU outputs it to any output device, which could be a monitor or speakers or even a printer. So again, if you are completely new to this, guys, it might be worth you going to find out a bit of information about all of these devices first. But what's important for today's lesson is that the CPU lies in the middle of all of these devices, which shows that it's pretty important, and it's going to be handling a lot of information, a lot of instructions, and completes what we call the Fetch-Decode-Execute Cycle when it comes to all of these things put together. So the first term we need to cover is the von Neumann architecture. And von Neumann was a guy in the 1940s who designed this concept of having a CPU and memory working together. So when we're talking about memory, we're talking about main memory or primary memory, also known as RAM. And this design, even though it was over 70 years ago, is still used in today's world. This concept of a stored program is where the program lives in RAM and the CPU is able to fetch and decode these instructions where it seems like one process going on together, when in fact it's two different components working together. So this term, von Neumann architecture, you literally have to just link it to this term, stored program concept, because this question I've seen quite a lot in past papers, and as long as you can describe the stored program being built up of a CPU and RAM, that's what the exam board want to see you be able to do. Okay, so von Neumann architecture, just link it to this term stored program with RAM and CPU working together and you should be okay. Like I said, this topic can be quite complex and quite tricky to understand, but if it's just a case of memorizing these keywords together, then that will allow you to answer a typical question around this subject. So when it comes to the CPU itself, it's built up of many different components inside. So although the CPU is simply just a microchip, there is a lot more to it considering there are so many parts inside, which again we need to show an understanding of. To a lot of my younger classes, the CPU is often referred to as the brain of the computer. Although a brain thinks for itself, a CPU doesn't. It just processes instructions that we give it. So the two main components inside the CPU are the control unit and the ALU. So we need to consider these as two major components, but then the registers consist of many small storage areas in which there are many of. Okay, so we're going to be coming to the registers soon. So all registers fall under the same category of a very fast memory location within the CPU. Okay, so it's actually inside the CPU, which means it's very fast. And it's a storage location where we can store things like instructions or addresses of instructions that the CPU needs to go and get from the RAM. And again, there are many registers that we need to know, and we'll take our time as we go through each one. We also have this term cache, which is also located on the CPU. It does a very similar job to RAM, or main memory, but it's much smaller. However, it's much faster. So if we take things out of RAM and put them in the cache, it means the CPU can get to this data quicker rather than going to RAM. So again, cache is located on the CPU, but it's not a component within the CPU, if that makes sense. And we will cover cache in more detail in a future lesson. These are the basics of a CPU and what the CPU is made up of. So what we'll do, we'll start with the hardest one first, which are the registers. And like I said, there's a lot of acronyms here. And what I tell my students is that as long as they can remember what the acronyms stand for, this will give them a good chance of remembering what the register actually does and the job it serves to the CPU. And remember, these are all storage locations, but very small, very fast storage locations within the CPU. Okay, so the first one, the CIR, is the current instruction register. And this register stores the current instruction that's being decoded and executed by the CPU. So whatever instruction the CPU is doing at that very moment in time, this will be stored in the CIR. And again, the clue is kind of in the name because it's the current instruction that's being executed. So the CIR, if you remember what it stands for, you should be okay. The accumulator stores data to do with calculations which are being processed by the ALU. So the ALU we haven't covered yet, but the ALU is all about numbers, and always relate this back to maths. So we'll come to the ALU in a minute, but the accumulator is where it stores the data for any calculations taking place. So the CPU is adding two numbers together. It will store the answer in the accumulator, and then if it needs to do something with that answer, again, we know it's in the accumulator, so the CPU can do something else with it. So the accumulator links with the ALU, and again, we'll go over this in a couple of slides. The next two are very similar, and the MAR and the MDR are both memory registers, MAR being address and MDR being data. So these two are the ones that my students always remember, and the MAR simply stores an address of the location within RAM where the data or instruction is either being read or being written to. So if we just go back to the first slide, if we've got the CPU here and RAM over here, the CPU and RAM are constantly exchanging information and data between each other. And obviously this data needs to know where it's going. So the MAR will always tell the CPU whereabout in the RAM it needs to go to get the data or to store the data. The keyword address in the middle. The address is a location of where the data needs to go or needs to be read from. And likewise, the MDR is simply the data which has been taken or is going to RAM. So the MAR is the address and the MDR is the data. Kind of think of it as an envelope, and on the outside of the envelope you've got an address. So this is the MAR, but inside the envelope you've got the actual letter itself, and that will be the MDR. Or even a package. If you've ordered something online, it gets delivered to your house, the delivery driver knows where your house is because of the address, but inside the package is the actual data itself. So if you want to think of it as that, by all means do so. And then finally we have the PC, which is the program counter, which tells the CPU where to go next in order of the list of instructions it needs to execute. The CPU is dealing with millions of instructions per second, so think of it as having a massive list of chores to do or a list of tasks to complete, and the program counter tells the CPU which task comes next. Okay, so the program counter is the next instruction to be read. Okay, so you've got a list of chores: clean your room, take out the bins, and wash the car. Okay, the program counter currently on 1, so you're cleaning your room. Once you've done that, where do you go next? The program counter will tell you you need to go and empty the bins, and then you've done that, then it will tell you you need to go and wash your car. So it's the next instruction that you need to go and do, okay, or that the CPU needs to get from RAM. Okay, so remember, simply identifying what these abbreviations stand for will give you a good idea of what they actually do. Now, when it comes to the control unit, think of the control unit as the manager or the person in charge who's coordinating and controlling all of the activities that's going on within the CPU. If we just go back a slide, remember there's a lot of information being passed back and forward from the CPU, the RAM, and also input devices, output devices, and secondary storage. So there's information going up and down these arrows billions of times a second, which obviously needs to be managed. And this is what the control unit does. Not only does it do that, It also decodes an instruction, so converts the binary numbers that are being passed to the CPU into an instruction, so the CPU can then execute it, and also receives signals from the system clock, okay, which we haven't discussed and will be discussed in a later lesson. But to put it simply, with all of this information flowing around the computer, it's very important that everything stays in sync and that timing is perfect when it comes to data being passed around the computer, not just within the CPU and RAM, but to input and output devices as well. Okay, so the control unit is the one in charge. It directs the timing, the control of the data being passed around the CPU and around the computer as a whole. Now we'll come back to the ALU, or the arithmetic logic unit, and like I said, link this word to mathematics and you should be okay. Any arithmetic operations that take place will be carried out by the arithmetic logic unit. Okay, so the key word being arithmetic, we can tie this in with maths easily, and again, this works with the accumulator, like we said, to store any answers or data that is calculated from an arithmetic operation. So as you can see in the diagram here, in main memory, we've got two pieces of data. We've got x equaling 3 and y equaling 5. The data is passed into the ALU with the instruction of add. So the ALU has received an instruction to add x and y. X contains 3, y contains 5. So the accumulator will simply store the answer 8. If the accumulator needs to do something with the number 8, it will pass it back to the CPU and then receive more instructions to do something with that number. So the accumulator will store the answer and the ALU is where the operations take place. So here's how they all work together, and you are required to recall this diagram and explain what's going on at each stage. I have seen past paper questions where you are required to draw the structure of a processor and explain how it works with main memory in order to execute instructions. So around the outside, you can see all the registers that we've discussed. I've put an explanation underneath each register as a reminder of what it does. And you can see RAM here as an external component to the CPU, as all the other parts that are labelled are inside the CPU. They are registers and components inside the CPU. So before I explain what's going on in this diagram, I just want you to understand the next concept, which is the Fetch-Decode-Execute cycle, because I'm going to refer to this cycle when I explain how the diagram works. So the Fetch-Decode-Execute cycle are the three operations which the CPU does in order to process instructions. So the first step is that it fetches the instruction and any data involved from main memory. Okay, so RAM. Remember, RAM stores all of the data and the instructions that you are doing at that moment in time. So the CPU fetches this data and brings it back to the control unit. The control unit decodes the instruction, so it figures out what to do. It's executed, and then the cycle starts again. Okay, so the CPU is literally doing this cycle billions of times a second, and we'll talk more about the clock speed and the Fetch-Decode-Execute cycle more in a future lesson. But these three steps I'm going to refer to when I explain the diagram that you can see here. So the first thing that happens when the data or instruction is fetched, we start here in the program counter. So the program counter points to the next instruction that is going to be executed. The MAR, remember, is the address register. This gets the address from the PC, from the program counter, so that it can go to RAM and go to the correct location. Once it gets it, it picks it up and passes it to the MDR. Okay, so the MDR receives the data or the instruction, which is going to be sent back to the CIR. The CIR is the current instruction register, so that's the instruction that we're currently processing. So the MDR gives the data there, and the control unit will receive this information, decode it, or in other words, figure out what it needs to do, what the CPU is going to do next. From the decode stage is the execute stage, and then the control unit will decide where the information needs to go there, whether it goes to the accumulator, to the ALU, or back to the PC for the next instruction. If it needs to do some mathematics or some logic, it will go straight to the ALU, or if it needs to store data in the accumulator to be worked with by the ALU, it will go straight there instead. But as you can see, it deals with both of these, so the ALU can do any mathematical operations. Once it's done, the control unit will go to the PC, go to the next instruction, and it will repeat again. And it will keep doing this cycle as long as your computer is running. Another way I explain to my students is if we think of it as a chef in a kitchen making food. The fetch stage can be represented as the chef looking at a recipe book, and they go to the page of the book where the recipe is contained. That's kind of like fetching the instruction to be executed. The program counter we consider as the actual page in the book where we need to go to figure out what we're going to do. The chef then reads the instructions, so add 2 eggs or add flour, and the control unit is like the chef's brain saying, okay, let's crack the eggs, let's mix in the flour, but he figures out what to do next. The execution is where the chef needs to actually execute the instruction, and if he needs to work something out, such as adding 2 eggs or 3 eggs, he might use the ALU to calculate it. Then he stirs the eggs and the flour or whatever the instruction is, and then goes to the next step in the recipe. And that would be back to the program counter to get the next instruction. So a simple analogy, and if that doesn't make sense, then don't worry, but that's how I do explain to some of my younger students. So here you can see the whole process in a nice flow chart, and if you can remember this or recall this, then you'll be absolutely fine in the exam, because as you can see, it's quite a complex process involving a lot of new keywords, a lot of complex terminology. So if it's just a case of studying this image, guys, then by all means do so. And then the last thing we're going to cover before we finish the lesson is what we call buses. And buses are the wires inside the computer that simply connect everything together. So again, this diagram is something else you need to recall. And as you can see, we've got the CPU, we've got main memory, and any input and output devices. How the data is passed between all of these components is using the buses. So a bus, just like a bus transports people, within the computer, it transports data and instructions. The control bus, kind of like the control unit, is the one in charge. It has control signals, make sure everything's working in sync with each other, and there aren't any issues. The address bus simply transports memory addresses of where data or instructions need to be read from or written to. So the keyword is address. And the data bus is simply carrying data. Okay, so again, just remembering the three buses and the names of them will give you a good indication of what the bus does, but they are literally just wires inside the CPU and the computer that transport the data. And that's it for our first lesson in Unit 3, guys. A very complex topic. And if you made it this far with some understanding, then well done. But otherwise, go and watch the other videos first, come back to this one, and it might give you a better understanding, especially of how main memory works, secondary storage works. But the CPU being in the middle, one of the most important parts in the computer with a lot of stuff going on. Okay, so hope you've managed to follow along, and I will see you in the next lesson.